In this video I'm going to do a couple of examples using relative velocity situations and try and explain the language and the use of vectors to solve these. So we've got the formula, I've written it twice in two different slightly forms. In the last video I gave a sort of situation where each of these forms of the formula or rule or result might be useful. So let's think about example 1. A plane flies with an airspeed of 450 kilometers an hour on a bearing of 120 degrees. The wind is blowing from the west at 80 kilometers an hour. What is the actual velocity of the plane? Okay, there's a few things here that we need to know in order to be able to do this. One, of course, is to understand our compass bearings. So let's just make quickly sure that we understand we've got north, south, west, and east. So if the wind is blowing from the west, that means it's blowing to the east. So from the west means away from west and directly towards east. The other thing that we need to understand here is the word airspeed. So airspeed is a way of saying airspeed is the speed of, well, I guess normally we're talking about a plane, could be another flying object, speed of the plane relative to the wind or to the air. Alright, so we're trying to find the actual velocity of the plane. So let's write might be helpful to write our rule first. So velocity of plane is going to be equal to the velocity of the plane relative to the wind plus the velocity of the wind. And those are the two bits of information that we're given, aren't we? So the airspeed with its bearing gives us the velocity of the plane relative to the wind. So let's do a vector for that one. 450 kilometers an hour on a bearing of 120. So remember, bearings, we start at true north. So if this is true north, we go around to 120 degrees. So let's say that's, let's say that's something like that. So that was 120 degrees around there. And this one here has a magnitude of 450. Maybe I'll write it below that actually. So let's say 450 kilometers an hour. And then we've got the velocity of the wind, which is 80 kilometers an hour from the west. So that's going to be something like 80 from the west. So we're doing a vector sum of those two, and the vector sum of those two should give us the resultant vector here, which will be the velocity of the plane, the actual velocity of the plane. So we could use components here. We could express each of these velocities in terms of their sort of i's and j's, and obviously the 80 would be easy because it's just 80i, and the 450 we could express using 450 cos 120i plus 450 sine 120j. Or the other way we can do this here is to use our kind of triangle of forces, isn't it? So we would know, for example, that if this angle in here, well, how could we express this? We could sort of do another line there. So we know that using the U rule, because those two dashed lines are parallel lines, that this in here must be 180 minus 120, so that must be 60 degrees. So I'll put a little 60 in there and then adding on another 90 around there. That means that total angle in there, let me grab another color, this total angle around here is going to be 60 plus 90. So that's going to be 150 degrees. So then I could use my cosine rule, which says that that side of the triangle is going to be equal to 80 squared plus 450 squared minus 2 times 80 times 450 times the cosine of 150, and taking the square root of all of that. So let's grab our calculator and give this one a go. So what have we got? 80 squared plus 450 squared plus 2 times 450 times the cosine of 150. Alright, so all of that produces 374, let's say 0.5, as the magnitude of the velocity. And, whoa, hang on, 374.5 doesn't quite look right there. Should be more than 450, shouldn't it? So what have I done? Okay, I have forgotten to square the 80, and I also put a plus instead of a minus, so let's just copy that down and get those right. 520, that looks a bit better. Okay, so 520.8 kilometers an hour. And then what I want to do is find that little angle in there. So I've labeled that little angle alpha in there. We could find that using the sine rule and just take that away from 120 to get the bearing. So using the sine rule, I could say sine alpha over the side opposite it is equal to sine 150 over the side opposite it. And I don't have a lot of space here, but if you rearrange that, then you'd be taking the inverse sine. So let's go inverse sine of 80 sine 150, 80 times sine 150 divided by 520, or let's just say answer, since that's the last thing I did there. And that gives us 4.4 degrees. 4.4, that looks pretty good. So therefore the bearing must be 120 minus 4.4, mustn't it? So bearing is 120 minus 4.4, which is going to be equal to 115.6 degrees. Okay, so the true velocity of the boat is 520, or the plane rather, is 520 kilometers an hour on a bearing of about 115.6 degrees. Okay, second example. On the other side of the page, we've got a car driving north at 75 kilometers an hour away from a level crossing where a train is heading west at 120 kilometers an hour. What is the velocity of the train relative to the car? Okay, so let's draw our two vectors here. We've got a car heading north at 75 kilometers an hour. So we could call that, well, because that's the thing that we want to find the velocity relative to, or actually let's just call it velocity of car. Velocity of train is heading west. So the train's going west at 120 kilometers an hour, and we'll call that the velocity of the train. And we want to find the velocity of the train relative to the car. So in other words, we're saying it would be the same as the velocity of the train if the car was still. What would be the same as this situation? So using our formula there, it's going to be the velocity of the train minus the velocity of the car. So if we do that as a vector sum, velocity of the train, let's just move that up a bit, so velocity of the train minus the velocity of the car. So there's going to be the velocity of the train relative to the car. Now I guess because this one's a right angle triangle, it's going to be a little bit easier, isn't it? So the magnitude of that is just going to be the square root of 120 squared plus 75 squared, 120 squared plus 75 squared. The square root of that is about 141.5. And the direction, well, let's work out this one as the direction. So it would be the inverse tan, because tan of that angle would be opposite over adjacent, which would be 75 over 100. So the inverse tan of 75 over 120 would be equal to 32, pretty much exactly 32 degrees to a couple of decimal places. So we probably need to give a direction here. So let's make a statement. Velocity of train relative to car is 141.5 kilometers per hour. And what would that be? 32 degrees south. So at a direction of 32 degrees south of west.